Alright, in this video here, I'm going to do kind of a summary of all the different rules for the transformations of graphs of functions. So if you haven't seen all the videos I did, I made, I don't know, 5 or 6, actually 7 videos already, talking about the graphs of parent functions and then all the different rules for transformations and kind of going in depth on each individual rule. But I thought it would be good to do a video where I just kind of pull them all together and talk about all those rules at once and kind of see some of the similarities and the patterns in the rules. And then also we'll do one example where we don't do every single one of those rules, but a whole bunch of them put together in one single graph. All right, so I was going to write all this stuff on the board, but it's a lot of stuff to write, and the board is kind of small. And since I already had it on this piece of paper, I figured I would just hold it up to the camera and show you. So it's kind of a summary of all the rules for transformations. Right. So first thing, it's split up into two sides: the vertical side and the horizontal side. Right. For the vertical side, when you're doing transformations that affect the vertical, all the action is happening outside of the parent function, right? Numbers get added or subtracted or multiplied, or you have negatives outside of the parent function, and it affects the y coordinates of the graph of the parent function. On the other side, for the horizontal transformations, all the action is happening inside the parent function, right? So inside, whether it's a square root or an absolute value or something being squared or raised to a third power, that x that's inside that function, you can have a number added or subtracted to the x, or multiplied or divided, or a negative in there. So the action is happening inside the parent function, and it affects the x coordinates of the graph of the parent function. Right, so everything that affects the vertical is on the outside. Everything that affects the horizontal is on the inside. On the outside, it affects the y coordinates. On the inside, it affects the x coordinates. No matter what the transformation is, that's the general rule. All right, so if you understand that, then it makes remembering the rest of these rules a little bit easier. Right, so next up, the actual rules themselves, the shifts. Right, for the vertical shift is when you have a number added or subtracted, right? The f of x plus c or f of x minus c, a number added or subtracted outside the parent function. Again, it's on the outside, so it's affecting the y coordinate, which means it's going to be a vertical shift. All right, so you're adding a number, that number c, to the y coordinates of the graph of your parent function, or if it's f of x minus c, you're subtracting that number c from the y coordinates of the graph of your parent function. Right, and for horizontal shifts, is adding a number inside or inside the parent function, either adding or subtracting a number inside the parent function. Right, so shifts, either for the horizontal shift is shifting left and right. For the vertical shift, it's going up or down. Right, and again, it's just adding or subtracting. Right, so adding or subtracting is always just going to be a shift. Depending on where that number is added or subtracted. If it's on the outside, it's a vertical shift up or down. If it's inside the parent function, it's a horizontal shift left or right. Right? If you see the rules there for the horizontal shift. Another common thing with these rules of transformations is the stuff that happens inside the parent function that affects the horizontal direction tends to do the opposite of what you would think. Right? So if I have f of x minus c, right, so subtracting a number actually moves the graph to the right. We actually add that number c to all the x coordinates of the points on our parent function. Right, and f of x plus c, when I have a number added to the x inside the parent function, that actually moves the graph to the left, and I subtract that number c from all the x coordinates of the points on the parent function. Right, if you want an explanation of why that is, check out the video I did specifically on horizontal shifts, where I kind of went through the reasons of why it's kind of the opposite of what you would expect. Right, subtracting actually moves to the right, adding actually moves to the left. Right, so that's the shifts, the vertical and horizontal, adding or subtracting numbers either inside or outside. Next up are the reflections. Right, reflections happen when you have a negative involved. Right, so if we have y equals negative f of x, right, that's when we are going to reflect the graph in the x-axis. Right, the negative is happening outside of the parent function, which means it affects the vertical direction, which means flipping the graph over the x-axis. Right, it's that vertical flip, flipping it in the up and down direction. Right, so having that negative outside of the parent function, again, basically what that's happening there is making all the y coordinates negative. Right, so when all the y coordinates become negative, or negative y coordinates would become positive, it's switching the sign of all the y coordinates, and so what you end up with is the graph gets flipped over. Right, for the horizontal reflection, well, that's when you have the negative inside the parent function. Right, again, outside the parent function affects the vertical, inside affects the horizontal. Right, so if I have f of negative x, right, that's going to be a horizontal reflection. It's reflecting the graph over the y-axis. right? And what's actually happening there is all of the x coordinates on the graph of the parent function become negative, or they get the opposite sign of what the original x coordinates were. And when you switch the signs of the x coordinates, that flips that graph in the horizontal direction. It reflects it in the y-axis. All right, so again, negative means a reflection. Where that negative is tells you where it gets reflected. If it's on the outside, it reflects vertically. If it's on the inside, it reflects horizontally. All right, so again, if you get these basic patterns, like anything on the outside affects the vertical, anything on the inside affects the horizontal, and then you know that the negative is the reflection, well, negative on the outside is the vertical reflection, negative on the inside is the horizontal reflection, right? Instead of two different rules, it's really just one rule, and then just where that negative is, inside or outside, tells you vertical or horizontal. Just like the adding or subtracting is the rule for the shift, and then just inside or outside is horizontal or vertical. All right, and same idea with the last rules, which are the ones for the stretching and shrinking. Right, so stretching and shrinking happens when we have a number multiplying our function somehow. Right, if that number is outside the parent function, y equals c times f of x, well then that is going to be a vertical stretch or shrink. Again, it's on the outside of the parent function. It affects that vertical direction. Right, and there, once again, it makes sense. If we multiply by a number bigger than 1, it stretches out the graph in the vertical direction, right? So every y coordinate of my parent function gets multiplied by that number c. If that number c is less than 1, if it's between 0 and 1, then it shrinks the graph, right? We still multiply all the y coordinates by that number c, but when we multiply by a number less than 1, it makes the value smaller, and so the graph gets shrunk in that vertical direction. All right, so that's the vertical stretch and shrink. The horizontal stretch and shrink, well, that's what happens when we multiply a number inside the parent function. Right, so once again, multiplying by a number is a stretch or a shrink. If it happens on the outside, it's vertical. If it happens on the inside, it's horizontal. Right, again, some basic patterns, some basic rules that once you get the hang of them, it's not like it's 6 different rules you need to know. It's really 3, and then just inside or outside tells you horizontal or vertical. All right, so inside though, once again, just like with the horizontal shifts up above, it's the opposite of what you would expect. Right, so f of c times x is a horizontal stretch or shrink depending on whether that number is bigger than 1 or less than 1. If that number c is bigger than 1, it actually shrinks the graph by a factor of 1 over c. And if that number is less than 1, it actually stretches the graph by a factor of 1 over c. Right, just like with the horizontal shifts left and right, minus actually moves to the right and plus actually moves to the left. Well, with the horizontal stretch or shrink, multiplying by a bigger number actually shrinks it. Multiplying by a smaller number actually stretches it. All right, and again, on the video that I did for horizontal stretching and shrinking, I kind of explained why that is, so you can check out that video if you want to get the full explanation for it. Right, and all these things that we talk about doing with the y coordinates or the x coordinates refer to the points on the parent function, right? So you should know what the graphs of the parent functions look like and some of the points on the parent functions, and then you're just like adding or subtracting to the y coordinates or the x coordinates, or you're multiplying the x coordinates by a certain number. Right, so those are a basic summary of the rules of transformations. I hope holding that up like that was helpful. I hope you were able to read all the stuff that was on there. Like I said, I didn't want to have to write all that stuff on the board because that was a lot of information there. All right, so those are our basic rules for the graphs of transformations. Let's use those now to graph a difficult function, more difficult than any of the other ones I did on any of the videos so far. Here we've got f of x equals -3 times the square root of x minus 2 plus 4. All right, so if we have to graph a function using transformations, step number 1 is identify the parent function. Well, the major thing happening in this function is that square root. Right? Other than that, we have some addition, some subtraction, some multiplication with a negative here. But overall, this is a square root function, which means my parent function is going to be y equals the square root of x. All right, so I know that my parent function is the square root function. Next thing is, what does the graph of that parent function look like? All right, so the graph of y equals the square root of x, and again, this is one of those parent functions that you should know. It goes through the points 0, 0, 1, 1, and 4, 2. Right, those are some of the key points on the graph of y equals the square root of x. All right, so that's the graph of my parent function. Y equals square root of x. All right, so there's my parent function. That's what it looks like. Now, I'm going to take these 3 points that I have on here, 0, 0, 1, 1, and 4, 2, and apply transformations to those points to draw the graph of -3 times the square root of x minus 2 plus 4. All right, so let's do that. Now, when you're putting together all these different rules for transformations, the order that you do them can be important depending on whether or not you're likely to screw something up. The biggest thing is like the reflections, flipping it left and right or up or down. If you like shift the graph like left or right or up or down, and then try to reflect it, you could mess it up. So my advice is if you have a reflection involved, do the reflection part first. Or maybe do any of the multiplying and reflecting first, and then do like the adding and subtracting stuff, the shifts left and right or up or down. Do those parts last, right? If you do it that way, you'll be sure that you get it right. Whereas sometimes I've seen students, do the, let me move it over this way and up this way, and then when they flip it over, they flip it over kind of the wrong way, and it ends up in the wrong spot. All right, so good idea to do the the stretching and shrinking and the reflections first, and then the other stuff after that. All right, so let's identify all of the transformations that we have here. First off, we have a negative outside of my parent function, right? We have the parent function is that square root there. Anything happens outside of that affects the vertical direction, right? So the negative always means reflection, so it's a vertical reflection, right? So that's going to be a reflect in the x-axis, right? It's going to take this graph and flip it over this way. Right, it's going to take all those y coordinates and make them all negative, which flips it down. Right, that 3 that's multiplying the square root, that's going to be a vertical stretch. Right, again, outside of the parent function affects the vertical direction. Multiplying is stretching and shrinking, and when I multiply out here by a number bigger than 1, it stretches it out. So it's going to be a vertical stretch by a factor of 3. Right? I have that x minus 2 inside the square root function. So again, inside the parent function affects the horizontal direction. Minus 2 is actually going to be to the right 2 units. Remember, when it's inside the parent function, it's kind of the opposite of what you expect. Minus 2 actually moves the graph to the right 2. And then the plus 4, right, that plus 4 is outside of the parent function. It's outside of the square root, so it affects the vertical direction. And plus 4 is the shift up 4 units. All right, so again, knowing those 6 basic rules that I was just talking about, really it's 3 basic rules, and then knowing where it happens affects the horizontal or vertical. Right, so multiplying is the stretch, the negative is the reflection, the adding or subtracting is the shift. Right, inside affects the horizontal, outside affects the vertical. All right, so now we have to do all these things with this graph here. So like I just said a couple minutes ago, you want to do the reflecting and the stretching first before you start moving the shifts left or right or up or down. All right, so I want to stretch this by a factor of 3, which basically means all of my y coordinates get multiplied by 3. Right, literally, I'm taking the square root function and multiplying all my outputs times 3. Right, so the 1 here gets multiplied by 3, so that becomes the point 1, 3. The 2 here gets multiplied by 3, so that becomes the point 4, 6. Right, so this one here is the graph of 3 times the square root of x. Right? But then the negative of that means taking all those y coordinates and making them negative. So instead of 1, 3, it's going to come down here to 1, negative 3. And instead of 4, 6, it's going to come down here to 4, negative 6. Right? So that's my graph of negative 3 times the square root of x. Will be this graph I did, this dotted line down here, right? So that's negative 3 times the square root of x. Now that's the graph that I need to take and move to the right 2 and up 4, right? And notice when I did all those things, the first point here at 0, 0 didn't change. When I do stretching and shrinking and reflections, the point at the origin doesn't change. If your graph has a point at the origin, it won't change. Because then if I multiply things times 0, if I try to do the negative of 0, it just stays 0. Right? But now that point's going to change because I can move that point to the right 2 and up 4. Right, so now, each of the points that I have down here, I move right 2 and up 4. So 0, 0, I move it to the right 2 and up 4, and then here's my graph right here, or there's my point at 2, 4. And that's my first point on this graph. I take the point at 1, negative 3. I move it to the right 2, so it's over at x equals 3, and then up 4 is going to take me to y equals 1. So that's the point 3, comma 1. I take the point at 4, 6. I move it to the right 2, so over to x equals 6, and up 4 is going to take me to y equals negative 2. So it's going to be the point 6, negative 2, and there in black is my graph of negative 3 times the square root of x minus 2 plus 4. Again, doing the stretching and the reflections first and then doing the shifts after that is the best way to do it.